Hello and welcome to Lesson 8-7 on graphing linear inequalities. This is the last lesson in Chapter 8, so yay! We'll be moving on to 9 before you know it. In tonight's lesson, you're going to be able to graph linear inequalities. You're also going to be able to graph systems of linear inequalities. In the past, we just talked about how to graph linear equations. So this lesson just takes it one step further, and you'll see that and how it works in a moment. First, what is a linear inequality? Well, it's still a linear equation. So it's still a straight line on a coordinate plane, but instead of having an equal sign, it has that greater than, less than or equal to, or greater than or equal to sign. So how do we find solutions on it? On the last lesson, we talked about how you look for that point of intersection with the system. Well, in this one, we actually do some shading because there's many points that fit with inequalities. So we're going to get started right away so you can see it. Graphing inequality on a coordinate plane. A, it says y is greater than 2 times x plus 1. What I want you to do is first just think of how you would normally graph y equals 2 times x plus 1. Okay, so you graph them in the same way. So I find my points, and how we do this is with the slope and y-intercept. My y-intercept is 1, my slope is 2 over 1. And I just go ahead and plot those points on there. So I'm going, and there. Now, this is where it gets a little different, because usually we just make a straight line, and there we go. That's our graph. Except because we have this greater than, instead of using a solid line, we use a dotted line. We use a dotted line with just a greater than or less than symbol. The only time you use a solid line with inequalities if it's greater than or equal to or less than or equal to. So here, because it's just greater than, I'm going to make a dotted line to connect these and put my arrows at the end. Now, we need to see in what side. Is it going to be this side over here or this side over here, where all the solutions actually work in the equation? So what you do is you just pick some points anywhere on the graph really to test. So because I like to use positive numbers, I am going to use the point 4, 1. All right, and what you do is you take that point of intersection and test it now into this equation. So y is greater than 2 times x plus 1. Well, I'm saying y is 1, and I'm saying x is 4. So I go ahead and do this. 1 is greater than 8 plus 1. So I take a look, and I have this. 1 is greater than 9. Now, if it is true, you shade in that region of that point. If it is false, that means that is not true. That side is wrong, so it's the other side. Here, this is false. So instead of shading in the side with that coordinate in it, I'm going to shade in this side, because that side, all these points would work. Meaning I can choose any point on that side and it would be true. So for example, I could try -2, 1. And I can show you that it's going to be true if I try -2, 1. So if I go ahead and do that, 2 times -2 plus 1. -1 is greater than -4 plus 1. So I get -1 is greater than -3. So that is true. So again, if it's true, shade in that side. If it's false, shade in the other side. We'll practice again. Here we have this one. Graph y is less than or equal to 3x minus 2. So again, first I graph it like I normally would. Y-axis, I start at -2, then I go up 3 over 1. Okay, and then you do the opposite. There we go. Now this time, because it's less than or equal to, I use a solid line, meaning I just use my regular line. And there we go. Then again, step 2, test a point. And I think I'm going to test, let's try 5, 3. So I put that into the original equation. So 3 is less than or equal to 3 times 5 minus 2. And let's see if that's true or false. So 15 minus 2 is 13. So is 3 less than or equal to 13? Oh, yes, it is. 3 is less than it. So that is true. meaning I shade in that region. So anything on this side of the coordinate, I shade in. All right, I have one more problem, and now it's your turn. I would like you to solve this one, and when you're all done, come back and check your answer. So go ahead and pause me now, and when you're all done, come back and check your answer. All right, let's go ahead and do this one. So I go ahead and just plot those points on here. I'm trying to do it very quick, so because I'm sure you have this point down. You've been working very hard on this in class. So there. Ooh, except I should not have the solid line, should I? It should be dotted because it is just less than. So, excuse that blue line, it should be a dashed line. There we go. So it's actually a dashed line on that side. Now I choose a point, and this time I'm going to choose 3, 3. Now, more than likely, you did not choose the same number as me, and that's okay, because it should work the same way. So I have 3 is less than negative 2 times 3. So I end up with 3 is less than negative 6. That is false. And so because it is false, I must shade in the other region. There you go. So that is what your solution should look like. And again, I'm just trying to make it so it looks like I actually did a dotted line, since I got a little too excited or too happy with it. So yes, this is a dashed line. There we go. So that's the first half of your lesson. The next, actually I guess we first have an equation to do. So cashews cost $2 a package, pecans cost $4 a package. You plan to spend no more than $20, how many packages each can you buy? So your first step is to write an inequality. Well, I know I'm buying cashews and I'm buying pecans. Now, you could use the variable C and P, but I'm going to use X for cashews and, no, I'm going to switch that. I'm going to use Y for cashews and X for pecans. All right? And then I plan to spend no more than $20. So I have to use those pieces in here. Well, I know the cashews cost $2. So I have 2 times however many packages I buy, plus I'm buying so many pecans at $4 per package. And that is going to, I know, be either less than or equal to $20 because I don't want to spend more than that. So that's what my inequality would be. Then step 2 says solve it and then graph it. Well, so we need to solve for y. And again, the way we do it is make sure we get rid of that x on the other side, or to the other side first. So I have 2 times y is less than or equal to negative 4 times x plus 20. And I'm just going through those steps like we've done each time. And I'm left with y is less than or equal to negative 2 times x plus 10. So that's what I end up with. And again, I have that up here as well. So you just go ahead and graph it. And when you're all done, you see what would actually work. How many of each package could you buy? There we go. So, and because it's equal to, I can make a solid line this time. And again, it's the same stuff we've been working on, so you test a point. So let's see, I'm going to do 1, 1. So if I put in 1 for y and I put in 1 for x, I have to see if that's less than or equal to 20. So 2 plus 4 is less than or equal to 20. Well, that's 6. And that is true. 6 is less than. I don't have any clue what I was writing there. 6 is less than or equal to 20, so that's true. So I can shade in here. There we go. So that's the first half of the lesson. Now we're going to talk about systems. And again, that's when we just have 2 or more linear inequalities on the same coordinate plane. And the solution is that region that makes both of them true. So this time you're going to have a couple different colors working together in order to solve these. And again, how you solve them is how we've been solving all of them, just graphing them. So we're going to go through this real quick, and then I'm going to have you do one on your own, and we're going to be done for the night. So step 1 is graph the first inequality. And you'll notice I'm going to do them in different colors because that's going to help keep me organized. So I'm going to shade that one red. All right, y is greater than or equal to x plus 1. So I'm going to go ahead and do that one. Okay, and I take a look. Oh, I use a solid line because it is equal to. So I grab that one. Now I go through that first step. I have to find an answer that works for each. So I'm going to go ahead and do the 2, 1 here. So if I put that into an equation, 1 is greater than or equal to 2 plus 1. That means 1 is greater than or equal to 3. That is false. So I'm going to shade the other side red. There we go. Now, I'm going to have to do another one. So I want to do that in a different color. So I'm going to go ahead and do this one now in green. So I have to do y is less than 2x plus 3. So I start at 3, and then I go up 2, over 1, and I do that. There we go. And on this one, I use a dotted line because it's just less than. And now I have to shade the region that makes sense for this green one. So it's either going to be over here or over there. So I just go ahead and choose a point. And let's see, I am going to choose the point. You know what? Why don't I use 2, 1 again? Might as well. So y is less than 2 times x plus 3. So y is 1, 2, x is 2. So I have 1 is less than 7, which is true. So I shade on the side of this one. Now, what you're going to notice is, in between one area, you have both inequalities, and you find the region that's shaded twice. So in this case, right in here to here is where the inequality is true, because that's where it's shaded twice. All right, so, oh, I guess I didn't have another one for you. That's the lesson for tonight. You have a great night. I'll see you in class tomorrow.